All right. Today, then we're going to start chapter 10. And the first thing we're going to do in chapter 10 is talk about finding extrema. So if I am looking for local extrema, I can do one of two things. I can do the first derivative test, which says that a local minimum occurs when the derivative changes from negative to positive, and a local max occurs when the derivative changes from positive to negative. Or we could do the second derivative test. There, your local minimum occurs when the first derivative is equal to 0 or undefined, and the second derivative is positive, and the local max is like just the opposite. So that occurs again when the first derivative is 0 or undefined, and where the second derivative is negative. So next thing the other type of extrema you might be asked to find are absolute extrema. You'll only be asked to do that on a closed interval though. So to do that, we do a first or second, doesn't matter, derivative test to identify local extrema. Then we check the local extrema and the endpoints of that closed interval. To identify the smallest and largest values. So that's the gist of section 10.1. From here on out, all I'm going to do are some example problems. Ideally, you're going to do them with me. So I'll do like one or two of them by myself, and then we'll have you guys work on them, and we'll go through them afterwards. So you may want your calculator handy. So it says find the coordinates of the local maximum or minimum of the function 2x squared minus 12x plus 15 and identify it as a maximum or minimum. So again, if we're looking for local, we can do a first derivative test, or you could do a second derivative test. It doesn't matter. Okay, I'm going to do both of them here as an example, and it's always at your discretion kind of on which one you like to do. So for a first derivative test, I need to find the first thing I need to do is find the first derivative. So what will the derivative of 2x squared minus 12x plus 15 be? Minus 12. Everybody good with that? Now, I noticed that 4x minus 12 is a continuous function over its entire domain. It's a polynomial, right? So is it ever undefined? No. So all I need to do is just find where it's equal to 0. So I add 12 to both sides and divide by 4. So that will be the location of my my local maximum or minimum. Then I will pick a test value on either side of that number. So I chose 0 and 4. So when I do f prime of 0, I get negative 12. I don't really care about the number. What I care about is that it was negative. And when I do f prime of positive 4, I get 4. I don't really care about the number. What I care about is it being positive. Since we've moved from the first derivative being less than 0 to this first derivative being greater than 0, that tells me that this is a local minimum. So to find the coordinate now, I found that it occurs at x equals 3. To find the y coordinate, I need to go back to the original function and plug that in. So that's going to be 18 minus 36 plus 15, which I think is negative 3. So my answer would be the 0.3 negative 3, which is a local minimum.
How did you know there was a local minimum?
Because the first derivative moves from negative to positive. That's the local minimum, right? So if I go back and I look up here, local minimum occurs where it changes from negative to positive. Does that feel okay? We'll do the same thing now with the second derivative. So to do the second derivative test, I need to find the first derivative to start with and find out, again, I recognize that 4x minus 12 is never undefined. So all I need to do is set it equal to 0 and solve. So I get 3. And then to find whether that's a local minimum or maximum, I need to find the second derivative. What's the derivative of 4x minus 12? 4. And I know that f of 3 then is still equal to 4. And since that's greater than 0, that tells me that this is a local minimum. To find the y coordinate for that local minimum, I will plug 3 back into the original function. And again, I get negative 3. So I would be done 3, negative 3 is a local minimum.
So when it's a local minimum, we just plug it in.
Well, the problem asks to find the coordinates, so it wants the x and y. If it just wanted the location, x equals 3 would have been fine. The question asked for the coordinates, so I had to plug the 3 back into the original to get the y coordinate for it. The question may, depending on the question, it may just care about the x value, or it may want the y value, or it may want the coordinate pair x, y. So that'll vary in the direction of the problem. Does that feel okay? In general, does it matter which one you use? First derivative test or second derivative test? No, man. Anything you're going to see, you could do either one. Are there types of problems where like one of them is impractical and the other one is? Yeah, but you'll never see that in this class, so let's not worry about it. How's that sound to you guys? This feel okay though? Pretty relatively easy, right? You're just kind of like solving and then interpreting. So you have to remember the rules on how to interpret the things. But it shouldn't be too bad. All right. Let's do this next one. So here it says to find the x coordinates of all the local maxima and minima for the function and identify them as maxima or minima. So here it doesn't need the coordinate pair, right? So all I need to do is find the x and identify what it is. I don't need to plug it back in. Does everybody see the difference in the direction there? Okay. Because again, it's asking for local. I can do this as a first derivative test or second derivative test. We'll do it both ways, just so you guys get a feel for how both of them work, and then you are free to kind of pick and choose which one you'd want to do. Again, for the stuff you're going to see, I don't think one will be any easier than the other, but you're free to choose. All right. So the first derivative test, I need the first derivative. What is the first derivative of x cubed minus 4x squared minus 3x plus 12? You mean 8x? Great. Everybody feel okay there? Again, I recognize that that's a polynomial function, so it's defined everywhere. It's never undefined. So all I care about is where it's going to be equal to 0. Okay, I don't think you'll really see a problem like this where you can have a function that's undefined also, but not in this class, but it's a thing. So I need to solve the equation 3x squared minus 8x minus 3 equal to 0. How's the best way to solve something like that? A lot of crickets for a pretty easy question. What type of equation is this? Quadratic. How do we solve a quadratic equation? You could use the quadratic formula, or you could try factoring. Either one of those two is a decent idea. Both of them will work here. This is factorable, but what feature of this quadratic equation is going to make factoring a little bit more difficult? Yeah, the leading coefficient isn't 1. So I would probably just go ahead and use the quadratic formula every time I see that. You guys good with that? So the quadratic formula again is negative b plus or minus b squared minus 4ac all over 2a so negative 8 squared is 64. that's 12, and then negative 36, but it's minus a negative, so it's plus. 64 plus 36 is 100. The square root of 100 is just 10. So we have 18 over 6, which is just 3, or negative 2 over 6, or negative 1/3. Is everybody okay so far? Now that I've identified where the zeros are, I'm going to go ahead and make my sign diagram. So I'll pick a value less than negative 1/3, a value between negative 1/3 and 3, and then a value bigger than 3. And then we'll evaluate the derivative at each of those and see whether it's positive or negative. If I plug negative 1 in, I'm going to have 3 plus 8 minus 3. That's going to be positive. If I plug 0 in, I have 0 minus 3. That's going to be negative. If I plug 4 in, I'm going to have 48 minus 32 minus 3, which is also positive. So 1/3 goes from positive to negative, so that's a local max. Positive 3 goes from negative to positive, so that's a local min. And that'll answer the question for us, because it doesn't ask us for the coordinate pair, it just asks us for the x-coordinate and to identify whether they're local mins or local maxes. So far, so good. If I did this as a first derivative test, again, I start by finding that first derivative. I note that it's continuous everywhere, so I just have to worry about where it's equal to 0. I'd solve it the same way. I get the same two solutions. Now, to determine whether those are maximum or minimum, I'm going to look at the second derivative, which is going to be 6x minus 8. And then I'll plug in those two solutions to this. I notice that when I plug 3 in, that's positive. So that's a local minimum. And when I plug negative 1/3 in, that's going to be 1/3 is going to be negative, so that's a local maximum. So I'm, again, done there. Again, either way of approaching this problem is fine. Do you need to do it both ways? No! Please don't do it both ways unless you're like, think you made a mistake on one or something. You just want to double check it or something. But like, what else could you do to double check this? Just graph f of x on your calculator and look for do the min-max command on the graph. Like, calculator find these things for you also. Now I would expect on an IB exam this to be like a multi-part question where you can't get away with just like, yes, you found the minimum and maximum, but like you would have missed parts A, B, C, D where it's like, find the first derivative. You know, solve the first derivative equal to 0 and like done all these extra pieces that it would have wanted you to do on the way to saying what it was. Anyways, so far so good. Okay, let's do another. says given h of t equals 4t cubed plus 3t squared minus 6t with domain negative 3 over 2 less than or equal to t less than or equal to 2. Find the coordinates of all local extrema and classify them as minimums or maximums. And then write down the coordinates of the absolute maximum and absolute minimum. So to be able to do the absolute part, it has to be on a closed interval. So if that was negative 3 over 2 less than x less than 2, you could not do this problem. Okay, just letting you know. All right, so part A is just going to be we're just going to do our first or second derivative test. At this point, I'm going to stop doing both of them. Is that cool with everybody? Just in the interest of time. I'm just going to do these as first derivative tests. In particular, on a situation like this, it's often more convenient to do it as a first derivative test. All right, so we'll start by finding that first derivative. So far, so good. I observe that this is a polynomial function that's continuous over its entire domain, so I don't have to worry about that. I'm going to set this equal to 0 then and just worry about solving. Before I start doing this, though, what do you observe about the coefficients in this polynomial? Yeah, they're all divisible by 6. So like before I get going, I'm going to do that. Everybody's cool? And this one I'm going to solve by factoring because it should be pretty easy to do because I know it's going to look like this. I just have to figure out where the positive and negative goes. So I think the positive has to go here and the negative goes here because 2 times 1, or 2t times 1 is 2t, and then negative 1 times t is negative 1t, and 2t plus negative 1t is the 1t in the middle. So when I set those each equal to 0, I get 1/2 and negative 1. Observe that both of those are contained inside the interval for the function, right? That closed interval contains both of my numbers here. If that was not the case, I would probably think that I had made a mistake in my solving. Now, it's possible that somebody would be so tricky as to give you a problem like this and have one of the solutions to the derivative set equal to 0 not be on the interval, but I wouldn't do that. I don't think the IB would do that. If the textbook does that, I'm guessing it was a bad editing job by the authors because we've seen that happen a couple of times. All right, so we got those guys. So I'm going to make my sign diagram. So I'm going to do negative 3 over 2, 0, and then 1. Why didn't I do negative 2 over here? The lower bound for the domain is negative 3 over 2. Negative 2 is not actually in the domain. I don't think it would matter, but I'm going to do that anyway. Now, the nice part is that because I have the factored form, I'm going to worry about the fraction becomes less of a hassle here. So when I plug negative 3 over 2 into the first factor, I get a negative. When I plug it into the second factor, I get a negative, and the product of two negatives is a positive. When I plug 0 in, I get a negative times a positive. That's a negative. And then when I plug 1 in, I get a positive times a positive. That's positive. So what's negative 1? Is it a maximum or a minimum? We're going from positive to negative. It's a maximum. So the easy way to remember this is positive means increasing, and then negative means decreasing. So if I draw myself a little picture as I'm going from increasing to decreasing, what type of, is that a maximum or minimum, my picture? That's a max. So that's the way that I just remember it, is just like, what does the picture have to look like? So the 1/2 then is a minimum. Okay, so that's part A. For part B, now we need to find the absolutes. So I need to check, oops, it's H. I need to check the endpoints. That's 2. And then I need to check my local extrema. Everybody's okay with that? And I'm checking this with H, not H prime or H double prime. Oops. Now on a problem like this, where I have to do this checking and I have a bunch of numbers to check and some of them are fractions, which like makes the mental math kind of a hassle. I'm going to do this all in my calculator, but I'm going to do it in a kind of a clever way so that I don't have to keep typing this stuff in all over and over again. So what I'm going to do in my calculators, I'm just going to type in my function for h of t into the y equals here. And then I'm going to do like that y1 of. So that's what the solution is for negative 3/2. And I have positive 2. And I have negative 1. And then I have 1/2. So I have 2.25, 32, forgot those other ones already, 5 and negative 1.75. So what I'm looking for is the biggest value and the smallest value. So I can say that the point 2, 32 is my absolute max, and the point 1/2 negative 1.75 is my absolute min. Is everybody okay with that?
Does it matter if both your answers come out of the local?
It does not. They could come, both your answers could be the endpoints, both your answers could be the locals, you could have one of each. There's no way to tell, short of like, looking at the graph beforehand, which is kind of cheating. This was really helpful when I was a student though, like these methods, because what we had to do to find extrema. This was the first method that we got to consistently find extrema for functions. Because I didn't have a graphing calculator at my disposal. Would have had to like sketch a graph and be like, okay, well, in between, this spot and this spot, there had to be a local. What the x coordinate was. Could do a lot of guess and checking, but this was really cool. So far, so good. So again, the key giveaway, or we have to be careful in reading the directions as to like what they're asking for, right? If it's an absolute, if they're looking for absolute extrema, you have to make sure you find that closed interval there, because you need to remember to check those endpoints. All right, next example, a toy rocket is launched upwards into the air. Its vertical position, s meters above the ground at t seconds, is given by s of t equals negative 5t squared plus 18t plus 1. Find the average velocity over the time interval from 1 to 2 seconds. When we hear the term average velocity or average something, what are we thinking? You hear average. You think slope. Right? We talked about average rate of change and instantaneous rate of change earlier. As soon as I hear average, and then something that's a rate, velocity is a rate, right? It's like distance per time. Should be thinking slope. So to do that, I'm just going to be doing S2 minus S1 over 2 minus 1. And again, I'm going to just do this on the calculator. So that's 3 meters per second. Part B says find the instantaneous velocity at t equals 1 second. When you hear instantaneous, what are you thinking? You should be thinking derivative. So what we really want is s prime of 1, right? I'm just going to do that on my calculator. It's a reminder of how to do that. We could do it by hand also. So if I want the value of a derivative evaluated at a point, I do math, and I scroll down to command 8, which is the nderive option. Do it with respect to x. And now, remember, I had already typed in the equation for s of t into y1, right? So I'm just going to put y1 here rather than type the equation out by hand. And then x equals 1. So that's going to be 8 meters per second. Is everybody okay there? Okay. Part C says, find the maximum height reached by the toy rocket and the time at which this occurs. Notice they're not so specific as to ask about the absolute or local maximum here. But look at the function for s of t. What type of function is s of t? Quadratic. What shape is the graph of a quadratic? What's it called? Parabola. And looking at this equation, which way is that parabola going to open? Is it going to open up or down? Down. How many maxima can that have? If it's just opening down, just one. Whatever that one maximum is the absolute maximum, right? Because it's going to be the highest point regardless. Is everybody okay? This is why they weren't specific, because you could infer from the function that you have that, yeah, there's only one maximum here. It has to be the absolute because of the shape of the graph involved. Okay. So I'm just going to do this using a first derivative test. Again, I'm left with a polynomial function, which is continuous over its entire domain. So when I solve for t, I get 9 over 5 seconds. I guess I can confirm that is a absolute maximum by doing a first derivative test, or confirm that it's a maximum by doing a first derivative test. When I plug 0 in for this, I get a positive. When I plug 2 into this, I get a negative. So that is a local maximum. Everybody's okay there? And then to show that it's a overall maximum, if I look at the second derivative of this, that's negative 10, right? Since negative 10 is less than 0, that means that this is concave down. For all t, right? And since that is the case, we're concave down for all t, it's got to look like this. And since we have only one maximum, and our position then at that absolute max, I will just do on the calculator. Remember, the function for s of t is in y1. So I'm just going to do y1 of 9/5. So I get 17.2 meters per second. So it's like, I don't remember. I think it asks for the coordinates, right? Oh, no, it just asks for the maximum height. So that's this. Oh, boy. I hate the way the book did that. That was so dumb. Okay, that's fine. Boy, they made that a lot harder than they needed to. So just as an aside, instead of doing this, what the textbook did is it said it solved S of t equal to 0, and then used that as the closed interval to do that closed interval test. Because obviously the position of the rocket, if it's shooting like straight up or whatever, like at position 0, it's back on the ground again. That's like the end of your trip, which is fine, but like, ooh, that was a lot more work than what we did by just looking at the second derivative and observing that, hey, things concave down the whole time. So like any if we have a single maximum, it's the absolute maximum, which I like that a lot better. Yeah. All right, I think I got one more example to do, and then we can be done for today. How's that sound? Yeah, I thought it was pretty good, right? All right. Now here it says a fruit distributor has noticed that the weekly change in the price of apples can be modeled by the function PC, I hate that, equals negative 13 over 52 sine of 90 over 13 times the quantity x minus 5, where PC is the price of a kilogram of apples and x is the number of weeks since the start of the year. Part A, the fruit distributor would like to plan a sale when the price of apples will be at a minimum. What week should that be? Or should the sale be? And then the sales decrease when the price of apples approaches its maximum. In what week will the price of apples be highest? Okay. So, what do we do here? This is a little tricky because there's words in here that matter. It says that PC is the weekly change in the price of apples. What does that mean? So PC is the derivative with respect to x time of some price function. So PC is already a derivative. We're not going to be taking the derivative of PC unless you want to do a second derivative test, which I recommend against it because we don't know how to take the derivatives of functions like that because it's not in the form ax to the n. So let's just do a first derivative test on this. We're just going to set PC equal to 0 and solve. Now, who here wants to try to solve this algebraically? Negative 13 over 52 sine of 90 over 13 times quantity x minus 5 set equal to 0. Does that sound like fun? How else could you solve this? on your calculator. Now, important note here, what mode is our calculator going to be in for this problem? What do you guys think? Degrees or radians? Yeah. IB, in your IB class, your calculator is always in degree mode, which will be stinky for people like Maria in the other class who's in AP Calc, where your calculator is always in radian mode, and in this class where it's always in degree mode. Okay, I'm going to set a window now. X is the number of weeks since the start of the year. What's going to be a good range of values for X? Okay, starting at 0, what should it end at? How many weeks are in a year? Christian? 52. That's correct. Okay. And then, anybody been to the grocery store lately? What's an apple cost? How about like $1 or less? Everybody think that's probably a pretty reasonable apple cost? So the price change is probably going to be between, like negative 0.5 to positive 0.5, like between 50 cents up or 50 cents down. I'm just kind of guessing. Does that feel reasonable to you guys? Oops, I put those in the wrong spot. Okay. And then let's hit graph. Okay. All right, so how many candidates do I have? I have 2 solutions to the price change equaling 0, right? This one that's on the left, is that going to be a maximum or minimum? Great. How did you know it's a maximum? It's because prior to that, the derivative is positive. After that, the derivative is negative, because the graph is above the x-axis prior to that 0 and below the x-axis afterwards. And then likewise, the 0 on the right is going to be a minimum, because prior to that 0, the derivative is negative, and after that 0, the derivative is positive. Let's find those 2 values. So to do that, I'm just going to use my calculator. I'll go second trace and pick the 0 command. You guys all remember how to use the 0 command, I hope, right? It asks for 3 things: left bound, right bound, and guess. So you just move your cursor to the left of the 0, and then move it to the right of the 0, and then enter for the guess. So we have week 5. And then the other solution, second trace, 0 command. Left of the 0, that's fine. Right of the 0, that's fine. Guess wherever. And then week 31. And I would draw like a little sign diagram here. So I have 5 and 31. So here, PC is greater than 0, PC less than 0, PC greater than 0. I would just write that for my sign diagram. I wouldn't actually pick test values here to plug in. You could, but like the graph told me everything I needed. So this is my local max. This is my local min. So the sale wants to be where the price is at the minimum. So this should be my sale. We're at week 31. And then it says sales decrease when the price of Apple approaches its maximum. What week will the price of apples be the highest? Does everybody feel okay there? Okay. This is, I feel like, good enough for today. You guys were sports. Gave me some decent participation, some of us anyway. I'm going to stop here. So just as a reminder, for Sunday's problem set, you're looking at 9.3 and 9.4. And then we'll have 10.1 will be part of the chapter 10 problem set that won't be due till after we get back from break. But don't forget about your quiz. I'm going to go update my Notre Dame and everything here in a minute so that all those assignments are reflected there. But okie dokie artichokes.